Yeah, so today what we're going to do is talk about a lot of angles and a lot of angle definitions, okay? So first off, let's talk about the definition of just the word angle. An angle is formed by two rays with the same initial point. So the word ray might be confusing to you. So here's a ray, and they have to have the same initial point. So there's another ray. So that shape itself is called an angle. Okay? And we've discussed this a little bit about there being these little tick marks out here called degrees. Okay? And that's how we measure angles. Okay? There's an interior of an angle and an exterior, but the interior of the angle would be just whatever is on the inside there. The exterior of that angle might be out here. Okay? So the rays are called the sides of the angle, and the initial point is called the vertex. So actually, you know what? We have a picture below, so let's go ahead and use this. Name as many angles as you can in this figure. Well, how do you name angles? Well, angles can be named using one letter from the vertex or using three letters. So when naming with three letters, start with the point on one ray, then use the vertex, then the point from the other ray. So if I wanted to talk about just angle 1, for instance, and I wanted to name it with three letters, how would I name that one? You can't just say angle B because it's not precise enough. Yeah, so ABD, you'd have to say those 3 points in order. However, you have to also have an angle symbol in front. So you got to say angle ABD. Hey Joseph, you good? You here with me? Yep. All right. So the next piece, lost my other highlighter. Here it is. So the next one is this bottom piece. I see this angle, the pink angle. So if you're looking at the pink angle and you want to name it with three letters, we would name that one DB angle DBC. Okay, angle DBC. And then there's one other angle, and it's the largest angle. ABC, angle ABC. Perfect. All right. Now, you might have also used angle 1 or angle 2. And you can actually do that. Now that 1 and 2 don't actually have a value, so you can't say that they add up and they equal 3. Okay? Now you could say the measurement of the angle 1 plus the measurement of the angle 2 equals some measurement, but anyway, that's 5 angles that we could name. And also the lettering could be mixed up a little bit, but the B always has to be in the middle for these angles. All right? All right, so how about this one? Name the vertex of angle EFG. The vertex is point F. Okay, the sides. Well, the sides will be ray FE and ray FG. All right. Here's a quick question. What's the difference between if I put an M in front of the angle symbol and just the angle symbol itself? You might not know the answer to that quite yet because I haven't really done much of that yet. So if I put an M in front of the angle symbol, that's actually going to be a number. That's how much something is open. Okay? The M measure of angle ABC is a degree measure. But angle ABC is a geometric figure. Now, can a geometric figure be equal to a number? Think about that. Can I say triangle equals 5? That doesn't really make sense, right? Well, the same thing goes for segments. You cannot say a segment equals 5, but you can say that the length of a segment equals 5, right? So you could use the idea of measuring for segments, but you can't say segment equals. You would say the measure of that segment equals. The same thing goes with a protractor. When you're measuring an angle, you say that the measurement equals the number. You don't say that the angle equals the number. So let's look at these and see which ones are correct. So this right here is called a congruency sign, and that means I can put one on top of the other. So does it make sense to say that a number, I can move it and put the number on top of the same number? Not really, okay? So we're not going to use that congruency symbol, so this is wrong. How about this one? Can I say that the measurement equals 30 degrees? Participate, guys. Yes, okay. And then measurement is congruent to 30 degrees. No, you can't really say that symbol there. All right, how about this one? The measurement equals the angle. Remember, this is still a number. This is a number of degrees. Can we say a number of degrees equals a is congruent to a geometric figure? Think about it. Can I say that 37 will map exactly on top of angle ABC? No, that doesn't make sense. All right, so is congruent to means that I can do one of those translations, reflections, rotations, and put it exactly on top of. So that symbol doesn't really make sense there. All right, so let's keep going. This one says that D lies in the interior of angle ABC. So there's your definition of interior if you are unfamiliar with that. D, do you agree that is in the interior of it, right? If D is in the interior, then basically it just says that the top angle plus the bottom angle equals the whole angle itself. Measure of angle ABC. And this is just like the segment addition postulate, except that we're not dealing with segments anymore. We're dealing with angle measures. Okay. So if we're using the angle addition postulate and we're using this same picture, I'm going to actually sketch a new picture, but just so I can color it. So you've got the top angle ABD right there, and then you've got, I'll call this the bottom angle DBC. So let's call them yellow and pink. What would the yellow plus the pink equal? I'm sorry? Yeah, it would equal the whole angle, right? 42 degrees. Measurement of angle ABC. So really, in geometry, what you should be able to do is say that measure angle ABD plus measurement of angle DBC equals measurement of angle ABC, but that's just a lot of letters to write, and a lot of people are uncomfortable with that. And that's okay. It's okay to be uncomfortable. It's okay to learn, okay? But it's not okay to give up. So let's continue on our journey, right? Let's try to figure this thing out. So there's the yellow angle, and there's the pink angle, and this theorem tells me that I need to add those together. I'm sorry, it's a postulate. So if I'm adding those together and I have a 3x and a 2x, and I also have a 5 and a minus 3, what do they add up to be? 3x and 2x? 5x plus 5 minus 3. is just plus 2. So 5x plus 2 equals 42. Okay, now this is a linear equation and there are 2 more steps. The 2 more steps are to just subtract 2 and then to divide by 5. So after you subtract 2 and you divide by 5, tell me what you would get. Subtract 2, you get 40, yeah? And then take the 40 and you divide by 5 and you get, I think it's 8. So there's 8. But now this says I need to go back up and find the yellow angle. Alright, well the yellow angle was 3x plus 5, but we know what x is now, so 3 times 8 plus 5. 24 plus 5 is 29 degrees. DBC, the pink angle, 2x minus 3, but we already know what x is 8. So that's 16 minus 3, or 13. And then if you want to, you double check and add the 29 and 13 together and make sure that you get 42. Okay, so we're on to page 2 and we're talking about the angle bisector. We're kind of discovering some vocabulary of angles today. So here we go. This angle bisector, a segment, line, or ray that divides an angle into 2 congruent angles. So this says that ray BD, it looks like a line segment here, right? So technically I guess we should have a little arrow, but it doesn't matter. We can do this. BD bisects angle ABC. Write 3 equations that accurately represent this situation. Well, the first situation that I would do is just the same one that we already know. And that's basically that yellow plus pink equals the whole thing, right? So let's go ahead and write that equation. The measurement of angle ABD plus the measurement of angle DBC equals the whole thing, measurement angle ABC. So that's our first equation. That first equation, that's from the segment addition postulate. Okay. What else should we know? Well, let's read this word bisect again and make sure that we know what it means. The word angle bisector means that it's a segment, ray, line, or ray that divides an angle into 2 congruent angles. All right, so what does that word congruent mean? Remember our transformations unit? Congruent means that I could slide one exactly on top of the other one. Okay? Now, if I could slide this yellow one exactly on top of the pink one, what does that mean about their measurements? The measurements are the same. So how could I say that the measurements are the same by using an equation? The measurement of the yellow one, so the measurement of maybe angle ABD, equals, I used the wrong letter, ABD, and then measurement of angle DBC. Does that make sense? So that's from the word bisect. This says BD bisects. So that was an angle bisector. All right, so the third option, there's a third formula that you'll need to be familiar with. Now, if angles 1 and 2 are the same, then couldn't I take this, let's say I wanted to take this ABD, couldn't I substitute it in right here if they're the same? So how many of them would I have? I'd have 2 of these, right? So you could say that 2 of the pink ones, or 2 of the yellow ones, either way, 2 of them, 2 ABD, equals the whole thing. I promise I know my alphabet. That is D. 2 times ABD equals the whole thing, measurement of angle ABC. And its algebraic equivalent, you could say that measure of ABD equals half of the large angle. All right? So let's just stick with those three. So what can we do for number 7? I'll tell you what, I'm going to give you guys 5 minutes to try that one. So guys, this is pretty exciting the way you guys have attacked this problem. I liked what you did. There was a lot of people that went to this and they said that 2x plus 6 plus 38 equals 76. Now how in the world did they get the number 76? Well, they saw that this top one was 38, and they're using the word bisect. So if the top one's 38, the bottom one has to be 38. 38 plus 38 is 76. That's how they get that. But there were some other people that set up their equation, and they went immediately and just said that 2x plus 6 has to equal 38. Now, does that make sense? Is the yellow one supposed to be equal to the pink one? Right? Yeah. Yeah. So that's your pink one, or that's your yellow one, sorry, and that's your pink one. Right? They're equal. So, and the algebra actually works out too. Okay? So, you can solve the rest of this equation by saying that 2x equals 32 and that x equals 16. I'm sorry, that's not what the action steps. The action steps were to subtract 6 and then to divide by 2. All right, that's what we actually did. All right, so take a look at number 8. Using the same logic, if that's 47, what's this one? 47. So if they're both 47, then that means that 9x minus 14 should equal 47? I don't think so. Yeah, we have to add them together. So 80, 94. We'll add 14 to both sides. It gives me 108. And 108 divided by 9. I'll show you how to divide without a calculator. 9 goes into 10 once with 1 remaining. 9 goes into 18 twice. So x is 12. And these questions just said to solve for x. All right. So down here at the bottom is a ticket out the door, kind of a challenge question for you. I'm going to stop the video there, and I'm not going to record how to do that one.